So the convolution algorithm is also very simple. It's based on the convolution sum equation we saw in the theoretical part of the course. So we're going to design a very simple function that accepts 5 arguments. The first argument is going to be a pointer to the array containing the input signal. The second argument is going to be the pointer for the array we want to store the output in. And the third argument is going to be a pointer to the array containing the impulse response signal. The fourth argument is going to be the length of the input signal, and the last argument is going to be the length of the impulse response. So let's get to it. I'm going to come down here and I'm going to say void. I'm going to call this function very simply convolution, like this. And because we have 5 arguments, I'm going to write them vertically. And the first argument is a double pointer, and this one is sig src for source array. And the second argument is also of type double pointer, and this one is sig dest. So these are just descriptive names I'm trying to use over here. Sig src array means signal source array. Sig dest array means signal destination array, meaning the generated results array, if you may. So I put an underscore over here, and then the third one we're going to say double, and this is also a pointer, and we can say imp underscore, imp meaning impulse underscore response underscore arr for array. The fourth argument is of integer and it's just the source signal length, so we can just call it simply signal source length, like this. And the last argument is the impulse response length, so we can say imp underscore response underscore length, like this. So now let's go ahead to implement the actual function. So first of all, we have to initialize the destination array to 0. We have to make sure all members of the destination array are set to 0. So that is just being double sure. So we can do that. We can use a simple loop. But before we write that loop, let's create the iterators up here. I'm going to have int I and int j here. So I can just come here and say for I equals 0 and I is less than. So something interesting over here. If you remember from the theoretical class, we say if we convolve two signals, signal A and signal B, the resulting signal is going to have the length of A plus B. So over here, the length of the output signal is going to be the length of the source signal plus the impulse response. We're just using the impulse response as signal B here. Convolution happens with any two signals. Just that if you use a nice impulse response, such as a perfectly designed filter kernel, you end up with a well-defined frequency response in the output. So over here, we're just taking a normal 15 kilohertz and 1 kilohertz signal and then convolving it with a filter kernel designed to serve as a low-pass filter. But that filter kernel could be just another signal. We could be convolving a 1 kilohertz signal with a 100 kilohertz signal, and it also would generate results, and the results length is going to be the first signal plus the second signal. So I hope you get what I mean over here. So we are in this loop, we're going to initialize each member of the array, set them to 0, right? So we saying int I equals 0, I is less than, and this is where we say sig source length plus impulse response length, because that's going to be the length of the output array, and then I plus plus, like this. And we can come here and say sig underscore destination array index I equals 0, like this. So once that is done, once that initialization is done, we can come to the convolution algorithm itself. So this has two loops. It's called the outer loop and the inner loop. The outer loop begins like this: for I equals 0, I is less than the signal source length, I plus plus, and then we have the inner loop within, just like the convolution sum equation. If you break down the equation, this is what you get programmatically. So in the inner loop, we say for j equals 0, j is less than impulse response, length, and then j plus plus. Right, so with these two loops, now we have the equation coming here. And the equation is very simple. It's as simple as signal destination array index I plus j equals signal destination array index I plus j. We first accumulate plus j, and then plus signal source array I times impulse response array j. Signal source array index I times impulse response array index j. So that's the convolution sum equation right here. Let's go over it. We're saying signal destination array index I plus j equals signal destination array index I plus j plus signal source array index I times impulse response array index j. It looks good. So all we have to do is take the function prototype to the top and then test out the code and see if indeed our convolution algorithm is working perfectly.